Welcome back to Statistics with Dr. Platt, and we're going to be actually covering median in this section, as well as our 5-number summary and our box plot, which would wrap up our measures of center position and spread. And our median is the centermost value in an ordered data set. If there's an odd number of entries, then the median is the true central value. If there's an even number of entries, then the median is the mean of the two center values. This can be associated as part of a series of values called fractals, which divide or partition a ordered set into equal parts. The percentiles is divided into 100 equal parts. So we have the no numbers below it, so the 0th number, or the position in our lowest value, has nothing below it. Then each value has some fraction of the values below it up until you get to the top. So to find the percentile, you count the number of values below a value, the value of interest, add half to it, divide by the total number of values, and multiply by 100. Or to find the relative position of the number you're looking for, our value C, you multiply the total number of values by the percentile and divide by 100. If it is not a whole number, you round up. If it is a whole number, use a value halfway between that number and the next one up to find the value that represents that percentile. A decile is a group of 10% or 10 equal parts. Our quartiles are what interest us most. Our quartiles, denoted by Q1, Q2, and Q3, represent our 25th percentile, 50th percentile, and 75th percentile. The mean, or the median, is our 25th or 50th percentile, or our Q2, or halfway point. The median of our lower half of our data is Q1, or first quartile. And the value that is that halfway through our upper set of values is our third quartile. So for our values here, so we have our median that we found to be 20.5 and decided to rearrange the values to allow us better access to it for another feature in a moment. But we have our median computed by hand as being the halfway point of our list, and computed through using the formula median, in this case from B14 through B45. Our quartiles are the top 25%, the marks off the first quartile, and 25% of 32 is 8, so we go down 8 values. We have 17, our next value is 18, and the halfway point between them, 18, is our quartile 1. We can, once we figure out where our median value falls, and this 20 is the last value in our upper half, and taking the median of these top 16 values gives us our quartile 1 using our median from B24 to B29. Median of B30 through B45 gives us our quartile 3, the value that separates our bottom 75% from our upper 25%. In Excel, there are two versions of quartile. Quartile.inc gives us a value that is favored towards the mean, or toward the median, and it brings us up from our what would appear to be our quartile in our quartile 1, because there's 75% of data above it, so this gets pulled up. In quartile 3, there's 75% of data below it, so it appears to get pulled down. Our quartile.exclusive, which eliminates certain values before it does the computation, gives us a value that in the lowercase matches, but in the uppercase doesn't appear to. And it is just weird. So you can either use the median of the lower half, the upper half, and the whole thing, or the quartile inclusive. You just need to be careful what you do, although you can always do it by hand. Our 5 numbers are minimum, quarter 1, median, quarter 3, and maximum give us a set of 5 numbers that we can use to create a stem and leaf plot, a box and whisker plot. And with this, we have our value, our minimum value of 3 is shown here as a dot, and our 38 and 30 and 44 are dotted as well. But we see our median value is this line through the middle. Our quarter 1 value is here, our quarter 3 value is here. And in this case, we have a couple values that are called outliers, which are values that are far enough from the median to be considered unusual. So they're considered unusual, but let's see if we can figure out a more rigorous way to find those. And one way to do that is using what is called an interquartile range, or IQR, which is the range of values between Q3 and Q1. In this case, our interquartile range is 25 minus 18. Or 7. So there is a 7-point gap between our 25 percentile and our 75 percentile, or 25th and 75th. But that still doesn't help us explain our outliers. Well, our outliers are determined by the equation that takes Q1 and subtracts 1.5 times our interquartile range from the value. This is a fixed relationship. Lower usual value is determined by this. In this case, we have 18 minus 1.5 times our interquartile range of 7 gives us a value of 7.5. So any value that is below 7.5 can be considered an outlier. And our upper unusual value is computed by Q3 plus 1.5 times our interquartile range equals 25 plus 1.5 times 7 gives us 35.5. So any value above 35.5 would be considered unusual or an outlier. So the values of 7 are approximately equal to our 7.5, so they are not considered outliers in the programming of the stem and leaf plot, where 3 is. So our 5-number summary and our interquartile range are used to describe the relationship of how the value falls around our median, in a way analogous in some ways to how the z-score or standard deviations describe how the data falls around our mean. Okay, so that's it for this week. So good night, everybody.